Let's create the file Tower of Hanoi .js, and now let's create the function Tower of Hanoi, and let's pass n here. N is number of disks that we are having on the from rod. So here we will be passing from rod to rod, where eventually we have to get all the disks from the from rod, and auxiliary rod that will help us do this. So for the sequence is, first we will call Tower of Hanoi recursively to place n-1 disks from rod to aux rod, right? So that we can put the nth disk from the from rod directly to the to rod. So the first call is for n-1 disks. We are taking these disks from rod and we are placing them at the aux rod. So this is the from rod, which is from rod, and aux rod where we have to place these disks. That's why the to rod is aux rod in this case. And now the next step is to place the nth disk from the from rod to the to rod. So moving the nth disk from rod to the to rod. So now we have all the three disks. If we are having 4 disks, then we are having 3 disks at the aux rod and 1 disk at the to rod. Now we are going to take these n-1 disks again from aux rod and we're going to place them to the to rod. So Tower of Hanoi, again calling Tower of Hanoi recursively, and this call is for n-1 disks that are present at aux rod, and we have to place them on the top of the nth disk in the to rod. So the aux rod will be the from rod in this case, to rod will be the to rod, and from rod will work as auxiliary rod. Now the base case is if we are only having 1 disk, right? So if we are only having 1 disk, then we can directly take it from the from rod and we can directly put it to the to rod. So moving the disk 1 from rod to the to rod. That's it. So this is the implementation to Tower of Hanoi. So this is the base case. If this is not true, we will do this. Now let's invoke Tower of Hanoi with input parameters. First, let's pass number of disks. Let's take 4, and let's say the from rod is X, the to rod where we're gonna place all the disks is Y, and Z is the helping or auxiliary rod. So now let's run this on terminal. Let's go to recursion, and now let's run Tower of Hanoi. So this is the output, and at the end of this program we will be having all the 4 disks that were present at X. We will be having all of them at Y. So see, disk 4 from X to Y, disk 3 from Z to Y, disk 2 from X to Y, and disk 1 from Z to Y. So at the end we are having all the 4 disks at Y. So this is how it's gonna work. And if we talk about what is happening behind the scenes, then initially it is just dividing the problem into subproblem. So when you have 4 disks, it recursively calls the same function Tower of Hanoi for n-1, that is for 3 disks. So initially it just called the same function. This function has not put the disks at the aux rod yet, but we're sure that after the complete execution, we will be having all the disks from rod to the aux rod. How? This function for n equals to 3 is again going to call itself, and it is going to recursively put the top two disks n minus 1, 3 minus 1 which is 2 on some other rod, and then this call for n equals to 2 is again going to call itself recursively to put the first topmost disk on some other rod. And you know that we can shift one disk to another rod without any worries if it is smaller than the already placed one, right? And here it is the base case when we are only having one disk. So it puts the disk at the 2 rod for that call, and now the execution comes back to the last call for n equals to 2. And at this point, due to the last call for n equals to 1, we got one disk placed at the aux rod of this call. And now it puts the last disk left at the from rod to the 2 rod of this call. And then finally it brings the disk placed at the aux rod and put it over the disk present at the 2 rod. And this is how the execution for n equals to 2 completes, and everything is going to get repeated for n equals to 3, and after the complete execution for n equals to 4, we will be having all the disks placed at the right place.